Hello there, BoBo the Bitcoiner is back again. Today episode 107F, another refresher of how a transfer is transacted in the Bitcoin ecosystem. As the earlier previous episode explained, transfer is actually just a message. Alright, the message goes to every node in the Bitcoin network, and because every node is a server, every node carries a copy of Bitcoin blockchain. Every node carry a copy of the Bitcoin software. So it is easy for the node to verify the sender has enough Bitcoin to send or do not double spend. Okay, so let's understand the first part. So you see here, every node has run the input. This is the input through the hashing, all right, to come up with a result, which is in this case a transaction ID. Okay, since the same message, every node should come up with the same output as shown in the last episode, right? That means at all the nodes in the whole world, when the transaction happen, that means you send the amount, send to which address, at what time, you go to the hashing, the output will be always the same. So they always have the same, what we call a transaction ID. All right. Node then check with all the 20,000 nodes or server of the Bitcoin system to see if everybody carry the same result or the same ID of the transaction done. Okay, now as you can see, let me earlier the result is always the same, and once you clear through this stage, the transaction or what we call the approved ID will then move to the next stage of the transaction. Okay, as earlier I showed you a hashing function, the message go to cryptographic will come out this. Okay. But if you add in a dot, you see it's completely two different results. Now two different ID. Okay. Now let me give you a quiz now. What happens if the hash result is different on different nodes in the Bitcoin ecosystem? It can happen, of course. And it happened because someone meddled with the Bitcoin software on certain computer. Alright, now the software is corrupted. Or someone hacked into some of the nodes. After every hash function, the node will counter check with each other, alright, among themselves. I mean, this is where consensus function kicks in. A simple majority win. And if 51% of the node say this is the result that we have, that hash is accepted as true and correct transaction. Of course, those disturbed, corrupted, or hacked nodes will be thrown out of the system, and its IP address is banned from future participation. Simple, clean, and honest truth. This is the power of cryptographic hashing. No human involvement. All right. This first cryptographic hash, clean and honest transaction, then is known as UTXO, or the short form for unconfirmed transaction. It's considered unconfirmed transaction because you still have to go through the next stage, which is the final proof of work mining process. That is the final confirmation. So up to now, it's only first stage. It's called, the name is unconfirmed transaction. Then you go through the proof of work, that is final. Then it's clear, that is done. All right. Simple as that, right? Hope you enjoyed today's episode. See you in the next one. Bye-bye.